Right, hello everyone. This is the last section of notes for the year. For you juniors that signed up for AP Calc, we're probably going to have to do quite a bit more work on this at the beginning of next year because the unit circle is something that's going to show up in Calc a lot. Just being honest, the unit circle is really just a simple tool that we can use to evaluate certain trig functions faster than if we had a calculator, or even if I did not have a calculator, I can still evaluate some trig functions just by memory from recall. So just remember, if we go all the way around the unit circle, 0 to 360 degrees. So really, if I broke that up into degrees, this first little line, and you guys probably have noticed this on my floor of my room, I would have a line here, and a line here. So I could really, if I know this first quadrant, I can really figure out the rest of the unit circle pretty easily. I know that this first line right here is 30 degrees. So if I went around the unit circle, and I just did multiples of 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then I'm at 360 going all the way around once. If you know that the radian measure that goes with that is pi over 6, okay, 30 degrees is pi over 6. I can just use the fact that I went 30, 60, 90 and just did multiples of 30 and do the same thing with my radian measure. So right now at 30 degrees, I have 1 pi over 6. So at 60 degrees, I would have 2 pi over 6. And then I just need to reduce it. It's pi over 3. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Then we have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So I just filled out most of my unit circle just by that 30-degree measure and pi over 6. And the only thing I'm going to have to make sure I do with those pi over 6s is just reduce them if I need to. 8 pi over 6 reduces to 4 pi over 3. So the other one I really need to know is 45 degrees. Okay, 45 degrees in radian measures is pi over 4. So if I went around my unit circle using 45 degrees, 45, 90, 135, 180, 225, 270, 315, and 360. Basically adding 45 every single time. So here's my radian measure that goes along with 45 degrees. So I have 1 pi over 4. If I add another 45 degrees, I have 2 pi over 4. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And then the same thing as previous, I still have to reduce all of those fractions. So, instead of 2 pi over 4, I'm going to call that pi over 2 because that's what it reduces to. All right, so there's basically our unit circle going all the way around, working with radians and degrees. So one of the things that you're going to have to know kind of off the top of your head is where all of those degrees and radians are, just from memory. So if I say 5 pi over 3, you need to know, all right, that's down here in quadrant 4. There it is, 5 pi over 3. Okay, the other thing that goes along with our unit circle is basically if we followed along the unit circle, along the circumference, there we go, to the circumference, and really that arc going all the way around, that is our circle. We have all of these ordered pairs that show up along of our unit circle. These ordered pairs are really going to be the answers to our trig questions when they get asked. So I have, at 0 degrees or 360 degrees, either one if you go all the way around or just don't go around at all. That ordered pair is 1, 0, because I remember that the radius of our unit circle is 1. So 1, 0. At pi over 6 or 30 degrees, my units or my ordered pair is square root of 3 over 2 and 1/2. And the way that they got that is really just making a right triangle. I know that the radius of that is 1, so there's my hypotenuse. And then they're just using the fact that it's special right triangles to be able to get, it's a 30, 60, 90 right triangle. So I'm just using those properties to be able to get the rest of those sides. So I would know that this right here is 1/2, because it's always half of the hypotenuse, and this one right here would be square root of 3 over 2, because it's always a shorter leg multiplied by square root of 3. And then they're basically just using those right triangles to get all of these other ordered pairs. And the same thing as I said on the previous page, it's important because there's symmetry. If I just know the first quadrant, I can really reflect and get to my other quadrants, and I know all of those ordered pairs as well. There we go. So I know at pi over 4, that ordered pair is square root of 2 over 2 and square root of 2 over 2. At pi over 3, it's 1/2 and square root of 3 over 2. And then pi over 2 is just 0 and 1. So I can see these ordered pairs could just be reflected. Pi over 3 to 2 pi over 3. The x value just became negative, and I still have exactly the same y value. So there are a couple of things that you really need to know in terms of our answers here to be able to get our answers. All of your cosine values are going to be the x values of those ordered pairs, and then all of the sine values are going to be those y values of those ordered pairs. And if I wanted to find tangent, we just have to remember that tangent is sine over cosine. So they're going to ask you questions like, all right, what is cosine of 5 pi over 6? Those are the type of questions that you're going to have to know. So if I just go to 5 pi over 6, which is right here, there's 5 pi over 6. My ordered pair, what is the x value of that ordered pair? Negative square root of 3 over 2. That is how you are going to use the unit circle to get your answers. I go to that special or that particular part of our unit circle, 5 pi over 6. And since it's cosine, I need to know the x value of that ordered pair. So there's a couple of other things to keep in mind here in terms of where's cosine positive? Cosine is positive where x is positive. So cosine is going to be positive in the first quadrant and then also the fourth quadrant. Where's cosine negative? Where is x negative? In the second and third quadrant. If I look at sine, where's sine positive? Well, whereas your y value is positive. All of your y values are positive in the first and second quadrant. Where is where is sine negative? It's where your y values are negative. So down here in quadrants 3 and 4. Tangent, I would have to think a little bit more deeply about. Tangent is sine over cosine. So where's tangent positive? It would be where you would have a positive divided by a positive. So sine and cosine are both positive in quadrant 1. Another way that I could get a positive answer is if I had a negative divided by a negative. Cosine and sine are both negative in quadrant 3. So tangent's going to be positive in quadrant 1 and 3. It's going to be negative in the opposite places 2 and 4. All right, so on to the next page of our notes here. I'm going to go down to here. So this is really where we're talking about just evaluating certain parts of our unit circle. So like sine of 3 pi over 4. We don't really have to think of it in terms of y over r or what they're doing here. I just go to 3 pi over 4. So if I go back up to my unit circle, where's 3 pi over 4? It's right here. What's the y value? Square root of 2 over 2. That's the answer. If I want to know cosine of 3 pi over 4, I go to 3 pi over 4, and I'm looking at the x value. That's negative square root of 2 over 2. Sine of 7 pi over 4. Go to 7 pi over 4. What's the y value? Negative square root of 2 over 2. And then you're just adding fractions together. So that's really all we are doing with any of these answers is go to that particular radian measure and then evaluate it, whether it's going to be the x or y value. Some other things that I'm seeing in here, secant is 1 over cosine. So I'd have I should rewrite secant of 11 pi over 6 as 1 over cosine of 11 pi over 6. So I go to 11 pi over 6 and I look for the x value, and then I have a little bit of arithmetic to do there. Cosecant would be 1 over sine. So we're looking at 1 over sine of 4 pi divided by 2 is just 2 pi. So I would need to evaluate at 2 pi all the way around the circle. What is the y value? It's 0. That's why that answer is undefined. And then down here we have some negative angle measure. So just start and go in the opposite direction until you get to that angle measure, and you can use your unit circle to do that. On the last page, they're just kind of saying, hey, if this is this and this is this, where is your terminal angle located? So the first one that's there, and I just got to erase this so I can scroll down, is where's cosine positive? Where's cosine positive and tangent's negative? I kind of look at it a little bit different than they do. I know that cosine's positive. Cosine's positive in quadrants 1 and 4. Where's tangent negative? I know tangent is negative in 2 and 4. So where must theta be? Where's the common point between those two? It must be terminating in quadrant 4. B, where's cosine? Positive. Cosine's positive 1 and 4. Tangent's undefined, where you'd be dividing by 0. That's what would make it undefined. So tangent is sine over cosine. Okay, tangent is sine over cosine. So I need to think, where would I have cosine equaling 0? Cosine would equal 0. That's the x value at pi over 2 and 3 of pi over 2. So tangent's undefined at pi over 2 and 3 pi over 2. So if I'm looking for the angle that fits both of those, there's no angle that exists because it can't be in quadrant 1 and at pi over 2. Pi over 2 and 3 pi over 2 are not in a quadrant. That's on an axis. And the last two questions are really just the same, just kind of talking about it a little bit further. And really that kind of wraps up our notes for everything today. So if you guys have questions, just email me. And like I said, that's kind of it for this year. So once you guys have your work submitted, then, I guess technically for math, you are then on summer vacation. Whether that means you're done with school or you're coming back next year. I hope you guys have a good summer, and reach out if you need anything.